Hi everyone, welcome to today's webinar. I'm Andrew Norrie, I'm the Commercial Director at 3D Repo, and I'll be hosting today's webinar along with our Head of Graphics, Sebastian Friston, and we'll be looking at our latest integration that we brought out recently with the Unreal Engine. So I hope everyone's been pre-warned that today's webinar will be getting quite technical. We will be having a real deep dive into the deep inner workings of the plugin, how it works and how you can get started with it. But to start off with, I'll be taking you through a bit more of a lightweight introduction to what we do and how we do it. So we'll start off with an intro to 3D Repo platform as a whole, talking about how you can use it and what it's used for currently. We'll then delve into the current Unreal workflows that you might be using and the proposed workflow that we're talking about. And then we'll go into the more technical side where I'll hand over to Sebastian. He'll be looking at the how you can get started and a real technical deep dive into how the plugin works. And then at the end, hopefully we'll have a really good Q&A where you guys will have the chance to ask us both questions about how it can work and how you can get started with it. So to get started with 3D Repo, what I always like to start with our founding principles. Why do we do what we do? The first reason is that we find BIM software is too complex. So the idea of the 3D Repo platform is to give an accessible place for everyone to access data. We also think that BIM creates knowledge silos, so the people who use the BIM software and the people who don't can't often communicate, and 3D Repo helps break down those barriers, and having the introduction of things like the Unreal Engine can help to break that down into the visualization space as well. We know that interoperability is hard, so on these large multidisciplinary projects like the one you see on the screen there, loads of different softwares being used, loads of different file formats. How do you bring them all together? How do you break them down into a common data format, and then how do you use it in other tools such as Unreal in a cost-effective way? And we also believe that data should be non-proprietary without lock-in. So where 3D Repo will bring in proprietary file formats such as RVT and DGN, we do break them down and store them in open formats and allow you access to every single part of your data via our open APIs. And finally, and this one's probably most relevant for what we're talking about today, we realise that every project's different, so you will always have different project needs, clients will have different requirements. So using things like 3D Repo in conjunction with tools like Unreal can allow you to create customised experiences depending on those client requirements. So the 3D Repo platform itself, we ingest 3D models from various file formats into our cloud. We break them down, we store them in a database as objects, and then we optimize that data and serve it up to you in various ways. So we have a number of products on the platform. The first one is 3D Repo IO. This is a web-based platform used for federating models together, running things like clash and change detection, and running all of your issue tracking and this is our flagship product at the moment and where people come to view their models. We did release another product last year called Plan-Base. So this allows you to bring those same models into a publicly facing web platform. This is used mainly for community engagement and feedback at the planning stage. And more recently, we released a free product called 3D Send. So this will allow you to send those files to people kind of in like a WeTransfer, so you can upload and download files, but with the added advantage of being able to view and manage and view and rotate and look at them in the cloud directly in a web browser. So if you do send someone a Revit file, they don't have to download it and view it in Revit. But the bit we'll be talking about today is how we can then pull that data and serve it up to you for use in gaming engines such as Unity and more recently Unreal, and the Unreal ones are what we'll be concentrating on today, and how that automated workflow from your authoring tools through the cloud to the Unreal Engine can really help optimize the performance of your applications. Underneath that platform, it's all held up by our open API. So these are some of the integrations that either we've done or our clients have done. And these range from really embedded things like where we've taken the Synchro format and embedded it directly into 3D Repo so we can accept it and understand the 4D stuff that comes from Synchro, to examples where we have add-ons in the Autodesk App Store for Navisworks and Revit, but also ones that are more just ad hoc things that users can do, like pulling all of the data out of your model into Power BI to be able to manage it in there and view it against a set of EIR information. In terms of data consumption, this is quite important for the workflows that we'll be talking about today. We do have a number of plugins, mainly in the Autodesk space, for uploading the data directly from your authoring tool to the 3D Repo platform. We can directly upload as well, so you can upload an RVT or a DGN just straight to the cloud and it will process. But the bit that I'm really excited about, and the bit that I think is really important for what we're talking about today, is the connection to other things. So connections to CDEs to bring that data in and keep what you're doing, whether that be in the issue tracking and model management space, or with pushing that data further on to external applications such as Unreal. You're still keeping it within the workflow of the CDE, so it still has that approvals process behind it. It still complies with things like ISO 19650, and it's not something that's happening outside of the scope of your BIM process. In terms of security, we have ISO 9001 and 27001 certification, and we're Cyber Essential certified in the UK. Everything's encrypted, so whenever you're transferring data or storing data in the 3D Repo platform, it always has an encryption layer over the top of it. In terms of hosting, our main platform is hosted on AWS in London and Montreal, so there's two separate instances that you can connect to. But we can spin up 3D Repo for you on any private cloud of the major cloud providers anyway. And in theory, we can also put it as an on-premise solution. It is quite heavy though as a platform, so it does require a few servers. It's not just one thing that you can install. So now I want to have a look at some of the Unreal workflows that we're currently looking at, and that we hear that our clients are currently doing. So what we're talking about here with Unreal workflows is how we go from BIM data to viewing it in the Unreal Engine or a published application. So the first and most obvious one that we hear about is exporting FBX files and re-importing them. Obviously, this is in a way one of the quicker ways, but has its limitations, especially on large projects, and you do lose a lot of data in terms of the actual BIM metadata that sits behind it. The other most popular one that we probably see is people going through things like Datasmith and Optim, and then people complicate or can make that a bit more advanced with FME as well. These obviously add layers of complexity into what you're doing, and we've heard processes taking from hours for small models to up to weeks for some really big projects. And then obviously once it's in Unreal, you're developing your application, you're publishing it out for use by your client, which is then sent out. So you have a published application. The problem being that then if any changes happen, you're back to square one, coming back, re-importing, starting again, and having to re-import all of the packs from the Unreal Engine and republish the game and redistribute it back out to your users. So the workflow that we're proposing today is those models go into our cloud-based system, and as I said, get broken down automatically into the database and then re-optimized and created as data that can be streamed into Unreal for creation. The other major advantage to this, apart from speed, so the time taken from upload to 3D Repo to being able to view in Unreal is now talking from minutes to maybe a couple of hours for a huge project. But the real advantage is the published application has no data in it anymore. So we can send out a blank published application with no data, very lightweight, and it can go back and pull it at runtime from 3D Repo. The advantage of that being when anything changes, we can kind of remove Unreal Engine from the workflow a little bit, and your users can just pull directly from 3D Repo any of the projects that they have there. And I'll go into a bit about how that works in a minute. So in terms of the workflow, this is a bit of an example here of the Revit workflow. So within Revit, we have a set of plugins for 3D Repo, so we can come in here and set the level of detail of this model that we want to put in. So we can go from very low all the way up to a maximum. This is useful if there are certain areas of the model that you don't need that really high fidelity modeling to keep it lightweight. So we can upload that section to 3D Repo and then create another section. This time we'll hide the architecture and we'll change the LOD, and again go through, change the LOD again in another section, and then a final end section. So now we've uploaded 4 models to 3D Repo. Here we can now federate those together. So within 3D Repo, we select the models that we want to be put into one federation, and they're then grouped. So that group can then be opened in 3D Repo and viewed. So we have those 4 models that we uploaded all viewable as one, and we can go through and look at the different LODs that have now been uploaded. So we've got the high LOD and the low, and again high and low. The advantage being here as well, we're still retaining all of that BIM metadata in the database, so we can see all of the data as we click on it. It's going away and making API calls to the web to pull all of that information for us. And then this is a bit of a jump here, but this is a bit that Sebastian will be going through, is how we then load it into Unreal directly from the web at runtime and directly into the published game. So again, the game is just pulling this directly from the cloud into the application. So this opens up a whole world of possibilities, and one of the things that I think is really exciting, as I said earlier, is about the possibility of including CDEs in this. So here we can now envisage a workflow where we link the CDE to 3D Repo and 3D Repo to your published application, and suddenly you've got an Unreal application here that is within your CDE and ISO 19650 workflow. So a change is made, it's uploaded to A site or Procore or whatever your chosen project CDE is. It can be checked and assured, signed off, and then once pushed to 3D Repo, automatically converted and optimized for use in Unreal and pulled down into the application. All of this can happen without any manual intervention, apart from obviously someone saying, yes, I want to approve it, if you put an approvals process within that. So here, I just want to quickly explain the 3D Repo kind of structure, because it will help you make sense of what some of the stuff that Sebastian's going to show. So 3D Repo has a number of team spaces. So a team space is where all of the models are stored, and you can add users to a team space to give them access to various models and revisions and projects within that team space. So within a team space, we have projects. You can have multiple projects, and then within a project, we have models. And then those model containers contain revisions of that model. So here we have 4 revisions, and the latest one of those revisions is always the active one, or you could change which one's the active, but by default, it's the newest revision is always the active one. So out of those models, we can then create federations, and models are then linked into federations. So they're combined, as I did earlier in that video, where the 4 models were combined into one federation. And models can be part of more than one federation as well, so that if one model container gets updated, multiple federations get updated. So the part that's important for the integration is that what we're talking about is Unreal linking to a federation and us uploading revisions to containers. So you can see now that if this Unreal application is linked to this federation and I update this revision, because the federation always pulls the latest revision, the federation is going to update, and therefore Unreal is going to update automatically as well. Okay, so that's it for the brief introduction. Before we head on to hand over to Sebastian, I just wanted to launch a couple of polls that we've got here just to get some feedback from you guys. So the first one is, do you or your business have any existing experience with Unreal, and what are your current plans for it? So I'm just going to launch that now. So that should be live now within the GoToMeeting or GoToWebinar control panel. So if we could get your answers there, that would be great. While you're in there, please do check out the questions section where you can ask any questions, and we'll be coming back to them at the end for the Q&A session. We will try and keep an eye on it. If there's something really pertinent at the time, I'll try and stop Sebastian, but I think it's probably easier if, for most of the time, if we just carry on through. Just give you a couple more seconds on that poll. Okay, I think we've got that one. So I'm going to close that one now. I'm just going to open one more poll now. So this one is, what phase of the project are you typically involved yourself? So we're just interested in where you would be using Unreal. Is it as a design tool? Is it in the construction phase, or are you more in the facilities management digital twin space? Just really interested to find out. So just launch that one and give you a couple of minutes on that. In the meantime, I will stop sharing my screen and I'll hand over to Sebastian. Okay, Sebastian, I'm just making you presenter now. So Sebastian, you should be able to show your screen now. And thanks very much for filling in those polls, guys. I'll just close that one now.
Great. Thank you very much, Andrew, and good afternoon. Thank you all for coming. So again, my name is Sebastian. I'm the head of graphics at 3D Repo and the lead developer on the Unreal plugin. And today I want to give you an overview of the plugin, tell you all about its use case, what it does, and how it works. I know a number of you will have seen the plugin before, some won't, so I'll start with a brief introduction just to make sure we're all on the same page, and then pretty quickly get into the technical details. So just so we all have the same idea, the purpose of the plugin is to bring 3D geometry from the 3D Repo database into Unreal, and secondarily to provide a pointing code to query our web API, typically for information about the model that you just brought in. And this is so that applications can use 3D Repo as a simple, performant, and importantly, always up-to-date content delivery system, even for applications that are already built and delivered to customers. So the use case for this is that the plugin will be integrated, or it's intended to be integrated, into customer applications at the C++ level. So it's not a recreation of our viewer, which you may be familiar with. So let me show you. So Andrew, can everybody see my screen okay? I think that is it. Yes. So we have.
Sorry, it's on me. Yes, they can.
Thank you. So we have our web viewer. You can raise issues, you can perform measurements, you can even do a 3D diff between this model and previous revisions. And the intended user of this part of our offering would be your architectural, construction, engineering staff. The end user of the Unreal plugin would be your development staff, who will then write applications for your construction, engineering, and design staff, who would then use applications built around the data that the 3D Repo database would provide. And so with that, let me jump right in and start telling you all about the plugin. So I'll start with a brief tour of my project here. I have an instance of the Unreal editor, and I have an instance of Visual Studio running. This project here I began with is a standard C++ game project. So as if I were to go to the editor, I were to launch a new version of the editor. And I would select a standard game project, blank template, and C++, and create a project from scratch on disk, all standard. In addition to this standard C++ template project, I also have the Unreal plugin loaded, which I can see down here under the project or game plugins list. So it is a game or project plugin. We don't touch the engine code. It doesn't interfere with any kind of other Unreal workflow you might have going. You only bring it into the projects that need the 3D Repo data. And I also have down here a number of example materials, which I will get back to very shortly. So in the Visual Studio side, I have the standard pre-built engine from Epic. So again, we don't touch that. And this is the Visual Studio project for my project. And in here, I have the plugin as source. So we can deliver either a packaged plugin, or we can deliver the plugin as source. I believe the plugin that's on the web at the moment is the source version. So if you were to download, you'd get a zip file like this. In here would be this complete project with our example code and of course the plugin itself. So you would take that plugin folder, you would drop it into the plugins directory of your C++ Unreal project. Then you would hit generate Visual Studio project files, and you would have something that looks pretty much like this. So in addition to the plugin as source here, I also have a number of example source files. There are kind of two parts to these examples. The first one is our sample game module, and this is, if you like, the minimal working example for bringing 3D repo data into the Unreal scene. And then I also have a number of slightly more advanced examples that show you how to do things like highlighting and picking. These are subclasses of a game mode and a player controller for implementing your logic and input respectively. So now let me just jump back into the editor, and I just want to begin now by showing you the plugin in action. So I've popped into play in editor mode here. For those who perhaps not familiar with Unreal so much, what I'm looking at now in this window is effectively what I would have if I were to build my project right now and deliver it to a customer. So this is effectively running at real time. So I load up my play in editor mode, and then I bring up the console command with a tilde key. I'm just going to give a console command 3D repo import demo model and press enter. And you'll see that the sample Lego house we were looking at before in the web app loads up. It streams in piece by piece. I can now interact with that model. I can change the lighting additions in the scene, for example. I can say, take this model and move it around. So it's all fully interactive. And that would then be the beginning of your application. That's a warning because I moved the lights, in case anyone's worried. And so now let me explain what exactly is going on here when I walk through each of those steps. So I'll go back to Visual Studio and I'll start out in this sample game module. And what I have here is a number of commands to register console commands. So these are registered when the module starts up. This is the primary game module that we've created for this sample code. So again, this code is in the source of the C++ project. So this code would be what you would replace with your own application code if you were to use the plugin itself. And what the code we have here for the minimal working example one is a bunch of console commands that will load in some demo models into the scene. So what these do is these register console commands, which, if you've not used this before, simply binds a text string in the Unreal console to a particular method here in this module. So I can jump to that one here, and so all that's going to happen is when I type that, the control flow comes immediately here. For the point of view of the plugin, nothing else happens. So it's just a way for me to start this, to execute this function on the main thread. So this is the method that's interesting. This is the one that actually loads in the model from the 3D repo database. And as you can see, I need 2 or 3 things for this. I start out with my team space, a model ID, and an optional revision. So the team space and model ID, as Andrew spoke of, define where your model is located. I can get both of these from the web. So the Repo 3D demo is my team space, and this GUID here is my model ID. So I provide these to the import model function, and here is the core of this sample. So these few lines first get an interface to the plugin. They then set the host, which is the server containing the 3D Repo IO API. We set the API key. This is for authentication. You can get this API key from your team space. If I go to team spaces here and then profile, you'll see an API key there that can be generated on the web. Then I point the plugin towards a couple of assets. So these are the materials we saw before, and I'll get back to why it's important for the plugin to have these materials available. Once I've done that, I create an actor under which it's going to create the geometry for the model, and then finally I give the command, and the model at that team space model and revision, if any, will be loaded under that actor asynchronously and will appear in the game view. And so this is really as complex as it gets for loading a model. These few lines are all you need to go from a completely blank scene to having a model of any level of complexity visible in the Unreal Editor. And that's the typical process that we would expect most people to follow. This is all done at runtime, but we do have the option to support some other workflows, including loading this at design time. So this exact same command will work in the editor as well, actually out of play and edit mode, and I can populate my scene at design time. So I'll give that command one more time. And you can see it's loaded up again, but this time I can click on that model and I can see it in the world outliner and explore some properties of the imported actor here. So let me show you this model in the world outline here. So I'm just going to show actor components so we can see what this model consists of. And what we see here is actually not very much. When we import the model from the 3D Repo database, what we're loading in is a highly optimized scene graph, and that's being optimized for the CPU. So meshes, individual objects, of which there might be hundreds of thousands in a large architectural model, are batched into what we call super meshes, and we deliver a number of these super meshes. And these are batched together in order to reduce draw calls. So all the information is still in there, as it would have to be in order to do highlighting and other such per object operations. The geometry I should really want to emphasize is not touched. So what you see is a faithful recreation of what you see in your CAD application. We don't alter the geometry in any way. So the CPU load is pretty much the same. What we do is we reduce the GPU load is pretty much the same. What we do is we reduce the CPU load, the number of instructions required to get that geometry onto the screen. And so the scene graph, although it's not represented in the world outliner, is still there. It's just virtual. And we're just using the Unreal Engine to render as fast as possible. Also here, I can actually look at the types that the plugin creates when I import a model. So by default, the plugin will create transient types. So these are procedural mesh components and transient textures. And these objects can be created at runtime and design time in Unreal. However, if I want, I can also convert these to static types, so static meshes and non-transient textures, which I will do at design time by giving the instructions 3D Repo convert. Of course, these are just linked up to these command consoles for the sake of the sample. If you wanted, you would invoke these programmatically via some other part of your pipeline, wherever you wanted to call the appropriate functionality. So this is now going to bake this dynamic or this transient scene into types that can interact with Unreal's asset management and serialization system. So I've converted all my assets, and I can now save a map. And I can see that the types of the objects that make up this model have changed here. And I can also see now, if I go into meshes, I can explore these assets in exactly the same way I would as if they had imported by any other means, such as importing an OBJ or an FBX. And these can then, you could build these out into a static, completely offline build and deliver that application. Or you could generate pack files and stream those if you were so inclined. But just to emphasize, this step is of course entirely optional. The expected use case is that most people will load the data entirely at runtime, and it will just exist for the lifetime of that particular application. So with this mesh set up here in its static form, let me talk a bit about the super meshing or the batching that I referred to earlier. So there are kind of, obviously we batch multiple objects into super meshes for performance reasons, but we obviously need a way to distinguish them at runtime in order to do per object operations. There are 3 levels of data which are interesting to talk about here. So the first one, the lowest level, is the data embedded in the mesh itself. These are, if you're interested in the UV coordinates, and these are pointers to mesh, to object IDs. So they're just numbers that exist in the mesh, and these reference into a map which is stored at the top level here on the actor itself. And if I have show all advanced details on, I can see I actually have this property here, this ID map, which will give you the mapping between a simple number and this mesh ID. This mesh ID, this GUID here, is a unique identifier for the object throughout the entire 3D repo ecosystem. You can use this within the plugin, and you can also use that same ID on the web to query information about that object. And if I go back into code, I find the definition of the supermesh actor, which is just a subclass of the typical Unreal Engine actor. I can see that this ID map is a simple array property on that, which you can also query should you want to. The second level up is the metadata that's stored locally. So this would be on this actor here, would be things like the diffuse color and the highlighting state of a particular object. These exist on the actor and they are managed by uRepo supermesh map components. So these are actor components, and what they do is they manage these texture maps and provide a nice API for you to set and clear properties of those based on the mesh IDs, and then also update any materials as appropriate on the actor. The fact that they are textures is an implementation detail, but it's important because it means that those can also be queried in these materials. So if I open one of the materials now, this is a Unreal parameterized or dynamic instanced material. And what I have in it is I have 2 texture map parameters, parameterized texture map slots, and these correspond to the textures maintained by those components here on the actor. And so an instance of this dynamic material exists for each of the meshes in this model, and they'll all refer to the same maps here. In addition to these 2 slots, I have a 3D Repo sampler, which is a custom expression node, and this little snippet of HLSL will query these maps based on the identity of a sub-object as it's read from the mesh via the texture coordinates. And then once I have these parameters, I can control the behavior of or appearance of that object in this in the material itself. So you see in this material, I have my base color, and then based on the state of a flag in the highlight map, I can just change the output color from its native color to bright yellow. And if you want a simpler version of this, I can show the absolute minimum here. I have my ID, I have the diffuse map, I have a single sampler, and that goes out to the base color. So this really is all you would need to get started using the per object functionality in our super meshes. Now you'll note that I have 2 such parameter maps here on the actor. One of these is set in the supermesh actor defined in the plugin source itself, and the other one is defined on the actor in the sample code here. So the idea is that you can instantiate as many of these as you like or need to in order to enable your desired functionality in your application. So you would modify or create an alternative to this class and add as many of these as you desired. And to update these, you would use the same IDs as you would go to the web. So I'll come back to this bit a little later, but you can see here's an example of setting the highlight flag, and this mesh ID here would be that UID, for example, from the map that I showed earlier. And so the third level of information is the metadata about objects that doesn't exist locally but exists in the database, and that information would be queried on demand from our web API. So Unreal has a built-in HTTP request client, and we have a fully open web API. You can find it at 3drepo.github.io, and there's a read the docs here, and all of these are available for querying information about the model. So for example, if I were to pick an API, I go to get model settings, it gives me a prototype for URI, and if I just perform an HTTP GET request against this, I will get some information back. So I'll give it a query I prepared earlier. So you can see here I give the address of the server, I have the team space which goes in here, I have the model, which you'll note is the same one that is defined for the demo model. And then I give it my API key, and if I issue that request, I get a block of JSON with some information about the model. For example, I get the units here. And using that API, you can query information about the model in Unreal. So there is an example here of a sample web request manager. This sample will use will build an API, sorry, build a URI to get the full tree. So this will return the virtual scene graph, and it will pass it, the JSON, into a native representation of the scene graph, allowing it to be queried for other metadata about the full model. And again, the IDs, the mesh IDs used, they're consistent locally between the parameter maps and the web, so these APIs interoperate transparently. So I like to bring this all this together for the last bit, which I will walk through the highlighting example. So we do bring in, we bring it all at CPU level, and we do support collisions. So if I were to show you the player collision, you won't see anything now because we turn off collisions with the camera by default, which allows us in play mode to move through the mesh for the purposes of the sample. You can see if I've highlighted that object here, a flag has been set in the highlight map. And because I baked the static, that map is now persistent. But there is collision geometry set. So if I were to view visibility collision, you'll see the kind of geometry we would be displaying. So in order to use this to enable the highlighting functionality, I'm going to look at the second set of sample code we provide. And so what we've implemented here is a game mode base and a player controller. So the game mode base is the logical implementation, the implementation of the logic of the application, and the player controller processes the user input. What we do with the player controller is we bind an action to a method. This action binding system, this is an Unreal feature. If I go down to input under project settings, for example, I will see I have a number of bindings. I can create action mappings and I can name them. And what I've done is I've made one called on mouse click, and that's now associated with the left mouse button. So after this command here, when I click the left mouse button, I'll get a callback to my own player controller method. And so what this method does is it firstly gets the mesh ID under the cursor. And the way it does that is it uses the physics system, it identifies a ray from underneath the cursor out into the world. It then, using the line trace by single channel method on the world, it will find the geometry underneath that ray, the first bit of geometry it hits, as well as the actor to which that geometry belongs. And then what I can do is I can check if this actor that I've clicked on is a type known to the plugin. So if it implements this iRepo traceable interface here, and of course, if you want to implement that interface yourself, you can. You don't need to subclass from one of our actors. If it does implement the interface, I can then give the command get mesh ID from face, and what this does is it will return the ID, kind of as you'd expect, using the coordinate in the face that it hit. It'll return the ID from that ID map quite simply, and pass that result back up. So if I do have a valid mesh ID, I can now do two things in parallel. I can firstly use that ID to set the highlight or clear the highlight parameter, depending on what it's already set at. And I can then pass that ID directly into my wrapper that's around the web API. And this will then go to the web API, it'll get the tree, it'll pass the tree into a native representation, and I can query that native representation using that ID again. And in this case, what I'm doing is I'm just getting the name of that mesh and I'm writing it out to the console, which is the behavior you see here. Okay, and so that pretty much covers the functionality in the sample as it is now, and mostly what I wanted to say. So just to summarize, the plugin is now out in beta. You can download it from our website. The plugin is, again, it's intended for use by developers building internal applications. The expected use case is that your developers will use it to load data from 3D Repo at runtime and build your applications around it. However, we can also load models into the editor at design time. You either make static builds or to edit them, or to even generate streamable packs if you're so inclined. Regardless of which you pick, the plugin will deliver a highly optimized stream of data to the editor, a highly optimized scene graph. The model hierarchies are virtual, but the scene graph is still there. It's just on the web, it's virtual. And the APIs that you use in the plugin internally interoperate transparently with those from the web. And this is to maximize the performance and minimize loading times, all which is handled by our server. And again, just to pick up on what Andrew said, the ID that I've given here in this sample, this is a pointer, if you like, to the latest version of a container, of a model, of this model particularly on the web. If I were to take this model, if I were to update it, I were to move it around, change its color or the like, and upload a new revision, I would, when I reran that import operation, I would get the latest version of that model, even if this application had already been built, even if this ID were hard-coded, although obviously it does not have to be hard-coded. You can see there are a number of other, there's another console command here, which will allow you to specify any model in your team space and load that, again, all working at runtime. And all of that is to support the use of 3D Repo as a always-on, up-to-date content delivery system for your application. And so I will stop my screen sharing right there, and thank you very much for listening so far, and hopefully you can answer some questions.
Thanks very much, Sebastian. We've got my webcam back on as well. We've got a few questions come through, which is good. If you do have any questions, keep them coming in. And in the meantime as well, I'm just going to put up another poll about what file formats you're currently trying to work with to bring into Unreal. It's interesting for us to know where to concentrate on our plugin development. So I think these questions have been coming in since the beginning, Sebastian, so we might have covered them, but let's try and give a bit more detail where we can. So one person was asking what the issue. Does the geometry get optimized to enable very large model streaming? And if so, what does that look like? What is the largest model and at which frame rate?
So we don't optimize the geometry itself, and the reason being is that your architecture and design staff, we need to have full transparency, because if we were to render, if we were to deform the geometry or we were to reduce the level of detail in some way, for many people it would be totally fine and perhaps even helpful, but for some people it could result in information discrepancies between users of different applications. So all the mesh batching is doing is optimize the CPU side to reduce memory and to reduce the number of draw calls. We can load a number of very large models. I don't think we've topped out Unreal yet on any of our models. We do have some links to some much larger ones and screenshots of much larger ones. In terms of frame rate, it varies a lot depending on what features of Unreal you have running. So especially shadows, for example, the more nice lighting effects and such that you have, the lower the frame rate will be. But you can get real time 30 to 60 frames per second. At least I have on my computer on models with many millions of triangles and thousands or tens of thousands, 100,000 or so individual objects.
Okay. Yeah, and just on that optimization bit, we don't optimize in the cloud, but the plugin. So if you're using the plugins in at the moment, Revit or the new Civils 3D one, they do kind of optimize by taking different levels of detail. So they will change the geometry a bit there, but obviously that's user controlled, so it's not it's you doing it, so we're not so worried. Slight difference there. Will any of the features be made available through Blueprint to enable people without C++ experience? I think I can answer that. The answer is at the moment no. There are no plans for that. Is it a possibility? That's maybe more of a question for you, Sebastian, in terms of a technical. Could we do it?
Yeah, we absolutely can do it. The feedback we've had from customers at the moment is that most of them are building in C++ directly, but obviously that's just what we've had so far. So if there's feedback otherwise, we'd love to hear it. Technically speaking, it's not that difficult to do. It's mainly decorating certain functions. So technically feasible, absolutely.
Mm-hmm. Yeah, I think at the moment, obviously we're in a beta phase. We're trying to get some adoption. It's one of those things, see how far this goes and what people start using it for as to whether we go down a route like that. Will the plugin provide access to the underlying data for individual objects? And will this be available will this be available through Blueprint? So we've answered the Blueprint bit. Access to individual objects data. I think we covered that during the presentation, right? That we could get to the BIM data through the web API.
Yes, I might just expand on that a teeny bit. So obviously, because we don't modify the actual geometry that goes with the GPU, the data is there. We don't have an API to do that, but it's fairly easy to pull out the individual triangle. If you're talking about the CPU level, actually splitting it out into individual objects in C++, there's no API, but you could certainly do that with the information that we have in the current version.
Will the plugin support texture material changes in the future for a single mesh at runtime?
So we are working on textures now. That's almost done. That might even be, by the time you get a hold of the plugin, that might even be in there. In terms of when you say at runtime, obviously any of the parameter maps values can be changed at runtime, as you saw with highlighting. And it's not, the diffuse color didn't change, but I could have changed it. We could have written a sample that would edit that. It's not a special map, the fact that it's a diffuse color. So yes, we can change. You could change the texture either via the parameter maps or via the actual textures themselves on texture models that are coming to the version of the plugin. One caveat will be if you, depending on the number of models that you have, obviously the way it works now is each super mesh needs its own texture, but that should be mostly hidden. So yeah, so if you do your own batching, for example, of textures, that'll make changing a little harder, but we don't do texture atlasing on our server at the moment, so on the cloud at the moment. So it's a long-winded way of saying yes, it should be supported.
Okay, and there's one more here about, is it possible, I'll let you answer it, but is it possible to create one application that can pull multiple models? So could we like link up and pull all the models in the team space if we wanted to?
Yes, we can do that right now. If you give the load model command twice, it will load multiple models. You can either load them all under the same actor, or you can create multiple actors and load individual models under those actors and then control them independently. But it certainly does support loading multiple models from the same or even different team spaces.
Brilliant. And how are the models geolocated? Is it based on the data provided from the authoring application?
There's not geolocated yet, but that information is in our web API. So if you were in a push, you could do it, and it would likely get that on the roadmap as well.
Mm-hmm. So what's it bringing in at the moment then, just at origin?
It brings it at it puts all the model data underneath the, maybe I can put back to my screen. Yeah, so it builds in it pulls in all the model data under the top level actor. So it doesn't change the location of the actor. So if you move this around before, even while the models are being imported, they will all come in under this. So this, if you were to read in the model geolocation data from the web API, for example, you would probably set the location of this appropriately. So that's where it comes in right now. And of course, you could find on the web API, there'll be an API here for getting the geolocation data, which you could then read in and set accordingly.
Okay. Cool. I think we've covered everything that's been asked so far. We'll be here for a couple more minutes if there are any more questions. Just to cover off about availability. So as Sebastian said, the plugin is available for download. The plugin won't work with your free account though. So if you are a existing 3D Repo paid user on a project license or an enterprise account, just drop an email to your account manager and ask him to enable the Unreal integration, because we don't, by default, we don't create the Unreal information, so we just need to turn a flag on for you. If you're not a user at the moment with a paid account, get in touch anyway. I'm sure we can sort something out. We have pilot licenses available on both our project and enterprise level that we could get you started on to start testing this out, because we really do want people to start giving us some more feedback. All right, one more question. Is 3D diff and issues available through the API for display in Unreal? Issues, yes. 3D diff, I'm going to say no, because it's not an API level thing. It is something we could implement into Unreal in theory. It's not something that we have on the roadmap at the moment. 3D diff works in real time within the viewer that is on 3D Repo IO. But the issues API is fully available there, and you can pull in any of the issues information, including the pin locations and all of the data. Same for safety base, and I imagine same for the smart groups functionalities as well, Sebastian. So if I have any groupings on IO, I could pull them through and use them within Unreal.
Yeah, anything that is available on the public web API, you could get in Unreal. I will point out that we've implemented in the sample web request manager, in the sample, we've only implemented one API. So at the moment, you'd need to pass your own JSON, but you don't need any external libraries to do that. And obviously, supporting some APIs natively is things we could look at on the roadmap. But in terms of is it technically possible, absolutely.
Yeah. Okay, brilliant. Thanks very much, guys. This webinar is being recorded, so it will get edited tonight and sent out to everyone. Feel free to share it around. And as I said, if you do want to give it a try and you haven't got an account with us at the moment, just get in touch. You can email us support@3drepo.com and someone will get in touch with you, or use the live chat thing on 3drepo.com or 3drepo.io. Okay, brilliant. Thanks very much, Sebastian. Really appreciate today. It was a great demo, and hopefully everyone found it useful.
Okay, thank you. Thank you everyone for coming.
Cheers. Thanks, guys.